And welcome to this third lesson on physics. How much energy does it take to climb this mountain? Or how much work do you need to do? And in physics, those words are sort of interchangeable. When we talk about work done, what we're actually talking about is energy. So if you put a title, work done, in your book or on your Google Doc, and if you then explain that actually in physics, when we talk about work, we're not talking about a job or anything. What we're actually talking about is how much physical work you could do moving an object a certain distance, and to do that requires energy. So work and energy are interchangeable in physics. Some recap questions from previous topics to pause on and have a go at, and then to mark your own. Okay, so what does a definition of work done mean? How can we calculate work done? And what does it mean about energy transfer? And we've already said a bit of that. The more work you do, the more energy you use. So, every time Mr. O'Neill, wearing his best suit here, only wears that on Thursdays, as you know, if he teaches you. Every time Mr. O'Neill here takes a step up these stairs, then he is taking his, well, he's got a mass. So let's say, for example, his mass is 70 kilograms. And then, thanks to gravity, his mass causes a downward force called weight. So we know how much weight in newtons, and that would be roughly, we times it by 10 from last lesson for the gravitational field strength, and we've got 700 newtons. That's the force of Mr. O'Neill going down. The one that I've drawn here, the arrow in red. Colour that in properly. So, every time he moves 700 newtons up, he's using a bit of energy. So it's quite an easy one to remember. Best thing to do is work out your own work when you climb a set of stairs you've got at home, unless you live in a bungalow, and then you'll just have to imagine it. So, work done. Work done is the same as energy. Energy. And work done, to work it out for Mr. O'Neill, there he is. Looking a bit dapper. Oh. And there's the stairs. You might think that this isn't to scale, but if you remember, he's quite small and stairs are quite sort of normal. When he moves a step, if we know how far he's gone, so a distance, and we know the force he's moving, it's quite easy. Work equals force times distance. Sorry about that S there, and there's an I. Work is force times distance. Now, as I said, work is measured in the same as energy, so it's measured in joules, and force is measured in newtons, and distance measured in meters. So actually, 1 joule is the same as moving 1 newton 1 meter, because 1 times 1 is 1. Okay, and then energy transfer, well, the more work you do takes more energy. Some people use stair machines or step aerobics and stuff as a part of using up lots of energy to get fit. So there's lots of these little adverts for science related jobs, etc. When you put on your Apple Watch, or when you put on your Fitbit, or when you take steps and it works out the energy you use, lots of physics is behind that, because physics is working out the energy the average person uses when they move a certain amount of force in newtons, a certain amount of distance in meters. So therefore it can work out your work and tell you how many joules or calories or kilojoules you've used in a day. So all of these training apps and everything, and fitness trainers will be getting their people they work for to do a certain amount of work, use a certain amount of energy, and they'll increase that all the time for progressive overload. Okay, so we've got work equals force times distance. If we know, as I said, that the force here is 700 newtons, and if we know that the distance here is 2 meters tall, then it's a simple matter of work is 700 newtons times 2 meters equals 1,400 joules of energy. And that's how much Mr. O'Neill takes to go up here. Now the only thing with this is, if they gave it you in kilometers, you need to change it into meters. If they give you it in kilonewtons, I never even heard of them. If you'd have to change it into newtons. If they gave it you in kilograms, that's what I meant, not kilonewtons. If they gave it you in kilograms, then you use the equation from last lesson, which is force equals gravitational field strength times mass, and first of all you can convert it into newtons. Right. So work is force times distance. So when you take your work here, it's force times distance because they're next to each other. If you want to work out the force, it's work divided by distance, and if you want to work out the distance, its distance is work over force. So there's actually 3 equations. So what we've got is we've got work is force times distance, force is work divided by distance, and distance is work divided by force. We've done the worked example already. It was 1400 joules. Now, if he has used 1400 joules in my example to go 2 meters for 700 newtons, if it took him 20 seconds to do that, how much power did he use? And this is going back to physics 1. So in physics 1, there was a power equation, and the equation for power is power equals energy. Here's our energy up here, 1400, energy over time. Because power isn't how much energy you use, power is how fast you use that energy. So it's divided by time. Energy in joules, that's our work, time in seconds. So that extension one now should be fairly easy. Okay. On all of these are basic questions, and this one over here again uses the power equation from the previous slide to link it with physics 1. So most of these are working out just rearranging that basic equation. So could you have a go at least 5 of them? Try some different ones. Try and show you're working out. The reason we say show you're working is quite easy. Sometimes people end up with the wrong answer at the end of a 3-mark calculation, but you can still pick up 2 of the marks just for your working out, for knowing the right equations, etc. And then this is more challenging practice. So let's just go through one of them for you, because they look difficult, however they're not. Question number 9 here. Now I've got to make sure I got my calculator ready. And there it is. Right, question number 9 here. What work is done when an object of 41.2 kilonewtons is moved 84 meters? So all I have to do is work equals force times distance. I've got the right equation because I'm finding out work. My force is 41.2 kilonewtons and it's moved 84 meters. Now I don't do my calculation yet because the first thing I do is I go, it's not in newtons, it's in kilonewtons. That is wrong. So the first thing I do, kilo means 1,000, so now I have to times it by 1,000 and I end up with 41,200. So I end up with 41,200 times by 84, and that equals 41. I know most of you can do this in your head, but it's far too early in the morning. That means you use 3,460,800. 3,460,800 joules. Now, that's quite a long number to write. You may, for example, be asked a slightly trickier question, such as, put the answer in kilojoules. So now you divide it by 1,000 and we could end up with, 3,460.8 kilojoules. However, in this answer is actually made it a bit more complicated. Give your answer in standard form to two significant figures. So standard form, converting it further into 3, get rid of that. Now, what I will say at this stage is, if you get this answer, the one in the red box here, you've got most of the marks. So if the standard form and the significant figures is something that you struggle with, don't overly worry, get to that stage first. Now, I've only allowed two figures. 3.5 times 10, and then how many dots have I moved it? To the power of 6. So 3.5 times 10 to the... Why did I put 0.5 instead of 0.4? Well, the next number afterwards was a 6, so I rounded up from the 4 to a 5. Right, and then lastly, once you've tried some of those, that's a typical exam question. So have a go at that, send your work through to your teacher, and thank you for listening.